Where the last video cut out, we were discussing the fact that you will be responsible for the solo question and having a conversation and comparison with your neighbor the next time that you come into class. So now, because this lesson is all about factoring when a is equal to 1, I want you to go ahead and flip past a couple of pages to this page that has, or find this box that says special factoring patterns. And in special factoring patterns, these are special and they follow a very, very unique way of factoring. You don't just have to figure out what two numbers multiply together to equal your C term and together adds to equal your B term. Although you can use that, what these are shortcuts. And I want you guys to please make sure that you know and study these shortcuts. Please make sure that you know and study them. The first one is called difference of two squares that we lovingly call dots in our class. Dots, difference of two squares. And difference of two squares is factored like this. If you notice that A and B are perfect squares, which our perfect squares list, so I'm going to write out perfect. Blech. They are your numbers that are 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, 289, 324, 361, and 400. Sometimes you might see 625 as well. And what these are is these are your perfect square numbers, 1 through 20, except for this one, this is 25 squared. So you need to know and recognize when you see a difference of two perfect squares. You'll see a perfect square minus another perfect square. So in our easy example, what I have here is a squared minus b squared. If you notice that you have a difference of two perfect squares, the way you factor it automatically is in two parentheses. And yes, you would split apart the a squared into an a and an a. But essentially what we did here is we took the square root of a squared, and we know that the square and a square root eliminate each other, leaving us with the letter a. So that goes into the first position. The last position is the same exact thing. We take the square root of b squared. The b and the b square, the square and the square root eliminate, leaving us with just the letter b, and that goes into our last position. Then, how do you get a minus? Well, you multiply a positive times a negative, and so that is going to be your pattern. So when we look at x squared minus 4, the way that we're going to factor this is it's going to be this splitting apart the x squared into an x and an x, and the square root of 4 we know is 2. The only way to get a minus is a positive times a negative. And this works, and it feels really weird that that is our pattern that ends up working. So if you think about it, if you were to multiply x plus 2 times x minus 2, notice that x squared minus 4 is missing the b term. And when you FOIL this, like x times x is x squared, x times negative 2 is minus 2x, 2 times x is plus 2x, 2 times negative 2 is minus 4. Look at what happens in the center. Negative 2x and positive 2x, they cancel away, leaving us with x squared minus 4. So this is a pattern that mathematicians noticed, and I would like you guys to make sure that you know it as well. And that first pattern is called dots, difference of two perfect squares. The next one we call lovingly in our class PST, perfect square trinomial. And what you're going to notice in a perfect square trinomial is that the first term will be a perfect square value, the last term will be a perfect square value, and the middle term will be a special even number. So you want to look for that. Also look for this last term being a plus sign. That's another thing that's key here. So the middle term will be an even number, and it'll be a special even number. It'll be an even number where it's your A value times your B value doubled. So the pattern for this one is once again going to be 2 parentheses. And we are still going to take the square root of A squared, which is A, and that goes into your first position. We're still going to take the square root of B squared, which is B, that goes into the last position. And what goes inside is not going to be a plus and a minus, but instead it is going to be the sign of your B term. So if you see a plus sign, then that's going to mean that both parentheses will have pluses. If you see a minus sign, like down here, we'll split apart the A squared into an A and an A. The B's are going to take the square root of B squared, B and a B. This one's going to have minus signs because that's the sign of your B value. You don't have to write it as A plus B times A plus B. Another way that you might see it is A plus B squared. Or you might see it as A minus B squared. That's another way that you can write it as well. And that's called perfect square trinomial. So an example of that would be example number 5. In example number 5, notice that our first term is x squared. X squared is a perfect square because it actually has a square in it. 9 is a perfect square. And 6 is a special even number. If I were to take the square root of 9, which is 3, and double it, 2 times 3 is 6. So it's a very special even number. So the way that I'm going to factor this is 2 parentheses. The square root of x squared is x, that goes into the first position. The square root of 9 is 3, that goes into the last position. And my B value is a plus, so both of these will have a plus sign. You can also write this as x plus 3 squared. It doesn't matter which way you write it as long as it's accurate. For number 6, same thing. This has a perfect square first term, a perfect square last term, and the B value is a very special even number. If you were to take the square root of 4, that's 2, and double it, you'll get 4. So I'm going to write this as x minus, split apart the x squared into an x and an x. The square root of 4 is 2, and because my B value is minus, I'm going to have both of my signs be minuses. Or I can write this as x minus 2 squared. So now what you see down here is you see a pair, and the very first pair question is giving you a problem to try on your own. And I would like you to please go ahead and try that problem and be ready to discuss it the next time that I see you. So that concludes our lesson of factoring when A is equal to 1. If you have any questions over anything, once again, please feel free to email me. Otherwise, I hope you have a wonderful day.